Hello everyone, this is Homer White back again with some tips on using RStudio add-ins to do plotting with a graphical user interface. In the past you may have worked pretty hard to make good graphs using some kind of R plotting system, perhaps the base package, the lattice package, or the ggplot2 package. You may have found that if you want to make really fine publication-ready customized plots, you have to learn quite a bit about the details of coding in each of these graphical systems. Add-ins can make the process a little bit easier. So how do we use these add-ins? First of all, you have to make sure that you have a recent enough version of RStudio that supports the add-ins. If your version is recent enough, you'll see an add-ins button on the toolbar should your toolbar be visible. You can also check under Help about RStudio for a high enough version number. At the time of writing, the version is 99.891. You also need to have appropriate add-ins installed. They're installed as packages. If you look under Packages, to use the add-ins we're going to talk about today, you will need to find a package called addinplots. If that package is installed, you're ready to go. So, what's a typical way to use an add-in plot? Say you have an R Markdown file going. Perhaps it will become a data analysis report someday. Say that you've loaded up a package in one of the initial code chunks. And say you have a particular data frame in mind from one of those packages that you'd like to make a graph for. In this case, we're going to be looking at the CPS85 data frame, a random sample from the current population survey of 1985. This comes from the Mosaic data package, which is loaded automatically when you load the TigerStats package up here in this code chunk. You want to make sure that you have your package ready to go for analysis. In this case, there was an outlier, a person who made an extremely high salary for that time of $44.50 per hour. So we're going to exclude that outlier with this subset command in the code chunk here. This creates a new data frame with the outlier removed. We need to run this code chunk to get that data frame into our global environment. So we run the code chunk. We see that the data frame is in our global environment ready to go. Now, to actually produce a plot, we know that the code for that plot would go in its own code chunk. So we have a new code chunk down here on line 24, but you'll notice I've typed in the name of the data frame that involves the variables that we'll be using to make our plot. I simply select and highlight the text for that name. Then I head up to the add-ins button. We see a number of addinplot functions that come from the addinplots package. We can make a bar chart using the lattice graphing system, a box and whisker plot, a cloud plot, that's a three-dimensional scatter plot, a density plot, a histogram, or a two-dimensional scatter plot. If you end up with a lot of add-ins one day, don't worry, you can browse all of them using the button below. Why don't we make a box and whisker plot? Immediately you'll switch to your default browser with a whole new window open. You're inside a locally run Shiny app that delivers the add-in functionality to you. Let's say you want to make a box and whisker plot involving people's wages. The wage numerical variable is present to be selected, and a very simple box plot of the wages of all the people in the study appears. Say we're interested in knowing who gets paid more, men or women. Then we might choose to group by sex. And sure enough, the grouping occurs. Now look at what's going on here. You'll see that when I made my choices about the initial variable and the grouping variable sex, the machine responded with the kind of plot I wanted. Over on the right here is the code that would produce that plot in the lattice plotting system. Notice also that we're on one of three possible tabs in the add-in. We're in the grouping tab now. Whenever you're in a grouping tab in an addinplots add-in, you'll have the opportunity to break your data up within the same single panel. But you may wish to include more variables in your study. For example, someone might say, men are making more than women, not because of sex discrimination, but perhaps because men and women choose different sectors of employment, and men happen to choose those sectors that offer higher wages. Such a claim amounts to the claim that if somehow we could correct for sector of employment, if we could look at men and women's wages compared within each employment sector, that wage gap you see here would go away. We can investigate this question ourselves by going to the second tab, the Facet tab. Faceting is a process by which you produce multiple panels, each panel going along with specific values of some new variable. You can facet in the lattice system by any variable, a factor variable or a numerical variable. In this case, we want to facet by the factor variable sector. If for some reason on your browser you don't see that variable, it's probably because the variable appears too far down the list. But if you know about the variable, you can simply begin to type it in and then pick it out of what appears. Sector had 8 possible values, everything from service on down to clerical sectors. And this produces by default 8 panels in your box and whisker plots. That looks a little awkward, but it's okay. You can change the number of rows in your layout. Let's try 4 rows. You can change the number of columns. How about 2 columns? That looks a lot better. I'll point out here that you could also choose to facet by a second variable. That variable, for example, could be a numerical or a factor variable. If you choose to facet by a numerical variable, such as education, then you get quite a busy graph. By default, what happens when you facet by a numerical variable is that numerical variable, education in this case, is broken up into 2 groups of equal size. That's accomplished here by this code on the first line, where the function equal.count breaks the education variable into 2 groups. By default, there's a slight overlap, a 10% overlap between the 2 groups, and the breakup is actually done by that new variable, in this case called capital EDUC. If you wanted to change the name of that variable to something more descriptive, you could do so under the shingle name. So education makes a little bit better sense. And of course you can change how many groups to break the faceter into. In this case, I think I'm going to leave it at 2. Now I didn't really want to facet by education, so I'll just take that away. All you have to do is backspace. The new graph will appear, but you might have to readjust the desired number of rows and columns. There we go. Let's take a look at the third tab panel. It's called Other, and you'll find that the Other panel in addinplots gives you basically a large number of options associated with the final refinements of your plot. Things like axes, labels for them, other options. In this case, for a box and whisker plot, you have the option of adding something to the box plots themselves. For example, you might choose to add a violin plot or a strip plot, which gives you individual values as points, or you could even add both. In this case, I'll simply add a violin plot. I can play with the width of the box relative to the violin itself. If the violin appears to be obscuring the box too much, I can make it more transparent by changing the value of violin opacity. We always have the option to flip our axes if we like. In this case, I don't think it does a particularly good job. I'll flip back. You'll often see an option for black and white. If you need to print in black and white and the color defaults don't come out too well, choosing the black and white option in some cases can improve the appearance of your plot. In the case of violin plots, I don't think it's going to make much difference. You can add a title to your graph if you like. And you can adjust its size. You can add labels to the x-axis. How about sex? You can alter the label on the y-axis. How about hourly wage? Dollars per hour, giving the units. Once you're happy with your plot, come to the upper right corner and press the Done button. The app will go dead. You can just click it closed. When you return to RStudio, you'll find that the code chunk that contained the name of the data frame no longer contains the data frame name, but in its place includes the code that was used to produce the plot that satisfied you. Now if you knit the document, you'll see the plot. There we go. So that's how add-in plots work. Thank you for listening.